Welcome to Form 3 Work, Chapter 1, covering statistical methods. In this video, we will focus on several statistical methods, including compound bar graphs, proportional circles, and pie charts. Compound bar graphs are also known as cumulative or divided bar graphs. They show the total data of different components within a period, with each bar subdivided into component parts. They can be drawn horizontally or vertically. The construction involves finding cumulative totals, choosing a vertical scale, drawing the axes, plotting cumulative values, and using component values to subdivide the bars. Subdivide components in the first year with the longest component at the bottom. Other years should follow this arrangement. Remember to shade components differently and include a title, key, and labeled axes. Here is an example data table. Table 1 shows crops grown in Central Province over different years in tons, including tea, coffee, maize, and beans. This is an example of a compound bar graph, visually representing the data from the previous table, segmented by crop and year. Compound bar graphs provide a clear visual impression of total values, represent a wide range of data, allow easy comparison, and make reading totals simple. Disadvantages include the time required for drawing and calculations, difficulty in establishing individual component values at a glance, and limited capacity for components, which can sometimes lead to a wrong impression. Next, we look at proportional circles. Circles of varying sizes present different data sets. Each circle's size is proportional to the total value of the data it represents. Construction methods include using circles with diameters proportional to the total value, or using circles with areas proportional to the total square roots of the total values. For diameter proportional circles, round off the total, select a suitable scale for the diameter, and calculate the radius for drawing the circles. Here is an exercise to practice drawing proportional circles using the value of output in transport between 2000 to 2003 in millions of Kenyan shillings. For area proportional circles, the process involves finding the square root of each data set, choosing a scale to calculate the radii, and then drawing the circles using these radii. Finally, we discuss divided circles, also known as pie charts or pie graphs. A pie chart is a circle representing a single data set total, divided into sectors. Each sector is proportional to the value it represents, and values are converted into degrees. For construction, first, get the total value of the data. Then, convert the value of each component into degrees using the provided formula. Draw a circle using a compass, and measure and draw the calculated angles with a protractor, starting with the largest angle. Next, shade and label the segments with their names and values. Finally, write a title and a key for your pie chart. Here is an exercise. Use the table to draw a pie chart. The exercise data shows horticultural fruits produced in Kenya from 2000 to 2004 in tons, listing grapes, lemon, oranges, and mangoes, along with their respective quantities. This is an example of the resulting pie chart, representing the horticultural fruits produced in tons, clearly showing the proportions for each fruit type. Now let's explore proportional divided circles. The size of each circle is directly proportional to the total value of the given data. The construction procedure starts by finding the square root of the absolute values. The square root values are used as radii after selecting a suitable scale. Draw circles using the calculated radii, and then subdivide each circle into sectors to represent the data. Subdivide the circles according to the angles obtained and shade the sectors. Finally, provide a key, label the circles, and interpret the graph. Here is an exercise. Study the table and use it to draw proportional divided circles, representing the value of export crops from Kenya between 1990 and 1993 in million Kenyan shillings. Another exercise uses data on fruits produced in Kenya between 1977 and 1979 in tons. We will use this data to answer the questions that follow. The questions include drawing a compound bar graph and proportional divided circles, identifying the year with the highest tonnage, and listing advantages and disadvantages of using these methods to represent data. Moving to Chapter 2, Map Work. This chapter covers the identification and interpretation of physical features and human activities on topographical maps. We will also look at the enlargement and reduction of map sections and the drawing of cross-sections. When describing features on a map, factors to consider include the compass point and eastings and northings. For instance, many rivers may be found to the southeast, or a cattle dip may be to the west of eastings 50. Relief or physiographic regions are also important. Specific features are identified by their shape and height, such as highlands or escarpments. For example, a steep area is shown by close contours, or a main river might originate from a hill. Main physical features include natural landforms, vegetation, and drainage features. Interpretation relies on map symbols and the key. Landforms include slopes, hills, plateaus, and valleys, forming the relief of the land surface. Slope is the inclination or gradient of the land. Its characteristics are determined by the pattern and spacing of contours. Straight contours suggest a level surface, while close contours indicate steep slopes. The height of contours helps determine the general direction of the slope. We can identify different types of slopes, including steep, gentle, even, uneven, convex, and concave slopes. A steep slope is shown by very close contours, while gentle slopes have contours drawn far apart. An even slope has contours spaced at regular intervals. Uneven slopes show irregular contour spacing. A convex slope has closely packed contours on the lower grounds and spaced contours above. A concave slope has close contours at the top and widely spaced contours at the bottom. Hills are high grounds above the surrounding lower terrain. On maps, they are represented by circular contours with height increasing towards the center. A plateau is an upland area with a level surface, bounded by steeply falling slopes. It is shown by very close contours at the bottom and widely spaced contours at the summit. Escarpments are continuous faces of raised land. They feature a short, steep scarp slope on one side and a long, gentle dip slope on the opposite side. Valleys are elongated, low-lying parts of land, bounded by two facing slopes. They are indicated by U-shaped contours, with the sharp end of the U pointing towards higher ground. Ridges are narrow, elongated hills with steep slopes on all sides. They are shown by closely packed contours that descend on both sides. Ridges may include features like hills, cols, passes, or a watershed. A col, also known as a saddle, is a small hill between larger hills on a ridge, represented with no transport routes or rivers and typically no contours. A pass is a steep-sided gap in mountainous areas, providing a crossing point, shown with transport routes and also having no contours. This image illustrates some of the relief features we have just discussed. Plains are fairly level areas with a low altitude of about 600 meters. When describing relief on topographical maps, describe the general relief, state the highest and lowest parts using contours or spot heights, and look for valleys occupied by rivers. You should also divide the area into relief regions, explain the type and direction of the slope, and identify landforms present. Next, we cover vegetation. Main types include forests, scrub, woodland, bamboo, thicket, scattered trees, riverine trees, mangrove trees, papyrus reeds, and palm trees. Vegetation is indicated by symbols explained in the map key. To describe vegetation, identify the type, distribution, factors influencing distribution, and possible economic uses based on map evidence. Our third topic is drainage, which refers to water features on the Earth's surface. Main drainage features include rivers, swamps, reservoirs or lakes, springs, ponds, boreholes or wells, ditches, and canals. Drainage features are usually represented by the color blue. When describing drainage, identify the features and their location. State whether they are many or few, and indicate their type or state, such as whether they are permanent or seasonal.